Welcome to this movie showing how Design Data Manager integrates with IronCAD. DDM provides a rich and powerful set of data management tools to the IronCAD user, as well as facilitating collaboration amongst the design team. In the first part of the overview, we have a single part within our scene that is to be stored to DDM. Before storing to DDM, we add some information to the part properties, in this case a username and description. With the DDM integration, a new menu is available from the Add-in tab on the ribbon bar. Here we can see all of the commands needed to communicate between IronCAD and DDM. Note that the IronCAD Quick Launch toolbar can be customized with the DDM commands. To store our part to DDM, we select the Save option. Initially, the file is stored to our local working directory. Notice also that we've kept the IronCAD default scene name, as we're going to use DDM's auto number generator to assign a part number. The DDM Save window opens, allowing us to add any information that we require before completing the save. Notice that the part description from the IronCAD scene has transferred to the DDM description attribute. We assign a part number using the Generate Number button and then select from the list of numbering rules. The auto number generator is included out of the box and is configured by the DDM administrator. We also classify the part to make it easy to find in the future. Finally, we add a custom attribute. DDM comes with a number of system attributes, but custom attributes can be defined, again by the DDM administrator. Here we add a value for our preferred supplier attribute. With the attributes populated, we click OK to complete the save. A Save Progress dialog confirms that the part has been successfully stored to DDM. If we look again at the properties of the part, we can see that the part number has been populated, but in addition we see that the DDM attributes have been transferred to the IronCAD custom part properties. Here is the preferred supplier attribute that we added as a DDM custom attribute. To view the part in DDM, we use the Search and Open command to open the DDM user interface. The part is automatically stored to my workbench. It is owned by me, and at this stage I'm the only user that has permission to modify it. Other users will be able to load it, but will not be able to make any changes to it. Another quick way to find objects that we're working on is to use the My Recent Items search. Here we can see the shaft that was just stored to DDM. In the next part of the overview, we look at how to manage a scene file that consists of a number of parts. In this case, the user is developing a concept design scene, but still wants to store the scene to DDM during this phase. We have a scene with 3 parts. Properties are filled in against each part, including some custom part properties. Here we add custom part properties for preferred supplier and color. Next, we create an IronCAD assembly structure. This serves 2 purposes. It allows us to manage our properties at an assembly level over and above the part level, but it also indicates to DDM that this should be stored in the assembly class rather than as a part. The scene is now stored to DDM. As we are in the concept phase, we assign a concept number. The real assembly number will be allocated later once the design is complete. Notice again that the description is populated from the IronCAD assembly properties. Once we're ready to continue work on the assembly, we open DDM and load it from the Recent Items list. The design is now complete and ready for detailing. We want to break it down into individual components so that they're all stored to DDM. This is important for generating a DDM bill of materials, for component reuse on new designs, and for where used searches. DDM provides a useful utility for exporting individual parts to their own seam files, called export elements as seam files. The utility provides a dialog that allows us to select which items we want to export. We select the individual components and then click OK. We get confirmation from an export summary window that this process is complete. We are now ready to store the seam back to DDM. We're prompted to save each individual component. Notice that any part properties, including custom part properties, that existed on the parts in the scene are automatically transferred to DDM. Here we can see the color attribute and the preferred supplier values correctly populated. We continue to store the other components, giving part numbers as required. Again, the Save Progress dialog confirms that all scenes have been stored to DDM. If we open DDM, we can see the assembly and component parts all correctly stored. If we look at the assembly links, we can see all of the assembly dependencies. Finally, we want to convert from the concept number to a real assembly number before finalizing the design. With the scene open in session, we open the DDM properties and use the Alter Part Number button. This activates the auto number generator, where we can allocate and assign a new part number. Notice that the scene name is updated in session. In this part of the overview, we look at drawing management. We've created a drawing of the bearing assembly. Before storing it to DDM, we add a bill of materials table. We select a bill of materials template configured to show DDM attributes, including the part, issue or revision, and description. Our drawing is now complete, so we store it to DDM in exactly the same way as the seam files are stored. The Save dialog opens and we can see that the drawing number and description are populated from the associated scene. These can be modified if required. A PDF of the drawing is created and stored along with the native IronCAD drawing, and the drawing title block is populated with DDM attributes as shown. If we return to DDM, we can now see all objects that have been created in this session under My Recent Items. Office users that do not have access to IronCAD can view the 3D models by double-clicking on the thumbnail preview. The drawing PDF can be viewed in the same way. The design is now complete and ready for release. If we right-click on the top-level assembly drawing and select Release, we open the Release Manager. If we select Expand All, we see the full assembly structure, including any component drawings or related documents. In this case, we can see that the bearing housing has a material datasheet attached. We select all objects and then select the state that we want to change to, in this case Released. Note that the datasheet is highlighted in red. This is already released and its state can't be changed. Finally, we add some comments and click OK. We will now look at handling changes to released documents. We want to make a change to the bearing assembly, but because it is released, it is protected by the access controls and can't be modified. In this case, we want to create a new issue or revision of the assembly. To do this, we start by loading the assembly drawing into session. Next, we edit the scene and make the changes. In this case, we're going to replace the solid shaft with the hollow shaft created earlier. To add an item to the scene that's already been stored to DDM, we use the Load Subpart menu option. With the changes made, we return to the assembly drawing. By looking at the Bill of Materials table, we can confirm that the hollow shaft is now being used. Instead of using Save, we use the Save New Issue command. This opens the Issue or Revision Manager. We select both Drawing and Assembly and up-issue them to the next issue, Issue 2. Finally, we add a change number that may relate to an engineering change order. And then add some change notes. When the up issue is complete, the new issue remains open in session. Notice that the revision history is automatically populated onto the drawing title block. From DDM, we can see the new issue drawing and assembly in our recent items list. These are at a state of work, now waiting to be released. In the final part of the overview, we'll look at the DDM Bill of Materials editor. If we right-click the assembly record, we have an option to edit the Bill of Materials. The Bill of Materials is automatically generated when our assembly seam file is stored. We want to add some items that are not modelled to the Bill of Materials. These could be lubricants, adhesives, packaging or documentation, typically items that we do not model. To do this, we simply drag the relevant item from DDM to the Bill of Materials editor. First, I will tile my windows so that I can see them side by side. Then, using my favourite searches, I can find lubricants that are already stored to DDM. With the lubricant added, I add a quantity and a unit of measure. The Bill of Materials is now complete and ready for publishing, and the new revision of the assembly can be released. In this short overview, we have seen how DDM manages IronCAD scene files, how it handles the difference between part and assembly scenes, and we have seen drawings stored and how both scene and drawings are available to non-CAD users. We also covered release management, revision control, and bill of materials. Please view other DDM movies to see more of its capabilities, including document control and process management through graphical workflow. This concludes the DDM for IronCAD overview. For more information, please contact info@designdatamanager.com.